Okay, worked example 15. So the number of mosquitoes N around the dam on a certain night can be modelled by this equation, where T equals the hours after sunset. Find the initial number of mosquitoes. So whenever we're talking about doing something with the initial values, that is when T is equal to 0. So I'm going to substitute into the function that will return to me the number of mosquitoes because I want to know the initial number of mosquitoes. So N, we're substituting in 0, is equal to 400 over 2 times 0 plus 1 plus 100 times 0 plus 1,000. Now I could do this without a calculator by doing this here. 2 times 0 will make 0, so I've got 400 divided by 1, which will be 400 plus 0 plus 1,000, so it's 1,400 mosquitoes initially. Okay, so that is A. Now we're going to look at B, so the rate of change at any time. So if we're looking for the rate of change at any time, that means that we're looking for the first derivative. So that means that I want to find the derivative of our function for the number of mosquitoes derived with respect to time, which is going to be the derivative that is, the function that is stated, and we're going to take the derivative of it with respect to time. Now, every time I'm writing this, it's just to help me, in my mind, understand what we're looking for. So when I derive this n part, I'll end up with nothing. Let me start from the start. So here, this is like 400 multiplied by 1 over 2t plus 1. If I rewrite this, I could say that it's the same as doing 400 times 2t plus 1 to the power of negative 1. So as soon as I write it like this, I can see that it's going to be chain rule. So the derivative of the inside of this will be 2 multiplied by the derivative of the outside of this will become negative 2 bracket 2t plus 1 to the power of negative 2. Sorry, that should be negative 1 there. Okay, so now I have derived it. And then this part here, I'll have plus 100 because we'll take the t from there. So 400 times 2 will make 800 times negative 1 will be negative 800. 2t plus 1 to the power of negative 2 plus 100. So that is the derivative of that function with respect to t. So this will give me the rate of change at any time in the function. Now, if I want to find that change when t equals 4, let t equal 4 in dn over dt equals what? So minus 800, 2 times 4 plus 1 plus 100. Now I'm going to just chuck that in the calculator. So that's going to give me 90.123. Now that does not mean there are 90 mosquitoes. That means for every hour, 1 hour, 90 mosquitoes. It increases, for every 1 hour, it increases by 90 mosquitoes, okay, when the time is 4. Now, that is different to when time is equal to 3. I'd get a different number here because it's about the rate of its increase, and that means that we're looking for that first derivative.